Hey, math students. GED student Shelby messaged me and said she is just struggling with the concepts of LCD and LCM, also known as least common denominator and least common multiple. So I'm going to start here with the concept of least common multiple. Then we'll hit least common denominator in the next video. The two are definitely related. It's the same skill. So first of all, let's break down the definition of this word. Obviously, we can look at this one word at a time. Hopefully, we know what least means. Of course, we're like, oh yeah, we know what least means. It means smallest. Now, if I say common, again, that's another common English word that we know, it occurring all the time. Or if you say you have things in common, those are things that are shared. And so I'm going to say smallest shared. And then multiple. Multiple is really the only math word here that you need to understand. But the good news is it sounds like something we know about. Multiple sounds a lot like multiply, and in fact, they are related. Multiples are numbers on another numbers times table. I'll show you what I mean. So I'm going to call this the smallest shared times table fact. It's a kind of weird definition, but it's my simple way to think about it. Let me show you what I mean. So for example, if we were just talking about the multiples of, let's try 8. If I were talking about the multiples of 8, I would be talking about 8's times table. So 8 times 1 is 8, just the answers. 8 times 2 is 16. And you might be saying, Kate, I don't know my 8 times tables. That's fine. Then count by 8s. So 16, I'm going to use my fingers. 17, 18, 19, 20, 21, 22, 23, 24. I counted up by another 8. 25, 26, 27, 28, 29, 30, 31, 32. So there is no shame in counting by if you don't know your times tables. In fact, that is how you will better learn your times tables, okay? So I'm just kind of counting up here. 40, of course, 40 and another 8 would be 48. 49, 50, 51, 52, 53, 54, 55, 56. So on and so forth. In fact, these multiples will go on and on forever. I could keep counting by 8s until the end of time. There's no end to the list of multiples of 8. Let's compare that to, say, the multiples of 6. Again, I'm counting by 6. I would start with 6. So 6, 7, 8, 9, 10, 11, 12. Next one would be 18. Again, if you know your 6 times tables, it's going to go faster. If not, don't worry about it. We're just repeatedly adding 6. So 30, 31, 32, 33, 34, 35, 36. 36, 37, 38, 39, 40, 41, 42. There is no shame to counting by, okay? That's how these numbers are discovered. So what I want to point out to you is that 6 and 8 certainly have some common multiples. They have some numbers that appear on both of their times tables. Like, take a look here. Both the 8 times tables and the 6 times tables contain 24. Similarly, both the 8 times tables and the 6 times tables contain 48. And you know what? If I were to keep going, I would find even more numbers that they have in common. Again, they would have, an infinite number of common multiples. If I could keep counting for forever, I would never run out of common multiples, numbers that are shared on 6 and 8's times tables, okay? But notice, I don't want all the common multiples. I want a specific one. I'm asking for the least common multiple. The least common multiple. The first time, and this is my English easy definition of least common multiple. The least common multiple is the first time two numbers run into each other on their times tables. Or the first time they share a times table answer. So in the case of 6 and 8, for example, the least common multiple will be 24. Again, they have lots of common multiples, but the smallest one is 24. Okay, so this method of just listing out the times tables is easy when the numbers are relatively small. Or, for example, let's do example number 1. It says find the least common multiple of 3 and 5. So it would be really simple to just list out the 3 times tables. 3, 6, 9, 12, 15, 18, and I won't go on forever because I may have already passed sometimes I go back and forth between my two times tables. So there's my 3s, there's my 5s, 5, 10, 15. There's no reason to go on anymore because I found the first time that they run into each other. It's at 15. It's at 15. So what is the least common multiple of 3 and 5? Well, if I were writing this in math speak because I'm lazy, I would say the LCM of 3 and 5 is 15. I wrote that in a complete math sentence because I'm a math teacher. I like writing incomplete math sentences, but the answer here is definitely 15. The LCM is 15. Now, that's a really simple example. Very easy to do by just listing out times tables. Let's look at one more kind of like that. Example 2 says find the least common multiple of 8 and 9. Again, I could just list out their multiples and find the smallest one that they have in common, the least common multiple. So 8, 16, 24, 32, 40. Again, I'm just counting by 8s, and if you don't have them memorized, you could just count up. So like 56, 57, 58, 59, 60, 61, 62, 63, 64. Now, I might be kind of going back and forth here because I don't know if I found one in common yet. 9, 18, 27, 36. Do you guys know the trick for 9s? You go up by 10, down by 1. So from 0, 9, I went up by 10 to 1, and down by 1 from 9 to 8. Up another 10 from 10 to 20, down by 1 from 8 to 7, up by 10, 20 to 30, down by 1, 7 to 6. Again, we just see this up 10, down 1 pattern. So you can see if I go up 10 from 30, I'll have 40. Down 1 from 6, I'll have 5. 5, 4. Whoops. Okay. Up, down, up, down. So I haven't seen any numbers in common yet. Let me come back to my other list because I kind of bypassed. So from 64... going up 8, I would get to 72, and I can see here that I have 72. Now you can see on this problem, it took me a little longer to find a number that they have in common. So this method is the easiest method to think about. If I'm finding the least common multiple, the easiest thing to think about doing is just list out the multiples and find the first time they run into each other. Okay, now I have a lot of students who tell me, Kate, look, I noticed a pattern. They think it's so cool. They want to point it out to me. They said, look. The least common multiple of 15 is, or the least common multiple of 3 and 5 is 15. And I know something. I know 3 times 5 is 15. Look. And then they look at the next example and they say, Kate, look. The least common multiple of 8 and 9, I just discovered was 72. And I know that 8 times 9 is 72. And they go, oh, and they come to a false conclusion. They go, Kate, to find the LCM, you just multiply the two numbers together. Super simple. Your method's stupid. Your method's stupid and hard. Just try timesing. Okay. Guys, here's the deal. A method only works if it always works, okay? So is that true? Let's take a look at this next example. Example 3 says find the least common multiple of 10 and 15. Now, I'm sure you guys will agree with me that if I take 10 times 15, I'd get a pretty big number, 150. But is 150 the least common multiple of 10 and 15? Let's check it out by listing out our multiples and seeing what's the first time that these two times tables run into each other. Of course, if I was doing my 10 times tables, that's super easy. 10, 20, 30, 40, 50. You guys could probably do this for forever. And I do want to take it out. I probably would. I don't actually have to for this problem, but just to make my point, I'm going to take it all the way to 150. Okay, and let's think about 15. So 15 plus 15. Now, I could count up, but I don't have 15 fingers, so it might be easier just to add 15 and 15. Would give me 30. And if you can see I've already run into my 10 times tables very, very quickly, way before 150. Of course, I could keep adding 15s, and I would see other common multiples. So I added another 15 to that. I would be doing this on scratch paper, but I only have one screen for you guys. So the next one would give me 60. Adding another 15, I'd get 75, 90, 105, 120, 135, 150. So is it true that multiplying the two numbers together will give me a multiple? Well, of course it will give you a multiple, because if you multiply 10 and 15 together, I'm on the 10 times tables and I'm on the 15 times tables by definition. However, is it necessarily the least common multiple? No, look at this. 10 and 15 had 30 in common. They had 60 in common. They had 90 in common. They had 120 in common. They had tons of common multiples. It wasn't just 150 wasn't the least common multiple. So it's super important that you do not just multiply the two numbers together all the time. Now, bonus for my students who are really math thinkers. Multiplying the two numbers together will work sometimes. There's an if clause. If something is true, you can just multiply the two numbers together to find the LCM. But there has to be a condition that's true first. So I want you guys to think about that. Drop it in the comments if you think you know what has to be true. Let's have a conversation about it. What would have to be true for me to be able to just multiply two numbers together to find the LCM? Okay, but we'll save that for the answer to that for another video, because I want to talk about the problems where it would not be easy to just list the numbers. Let's take a look at example 14, or example 4, I'm sorry. It says find the least common multiple of 14 and 18. The first thing I want to say is I do not know my 14 times tables, okay? Not only do I not know my 14 times tables, it would be challenging to count by 14s because, hello, that's a lot of fingers. It would be easy to make a mistake. Now, I could add 14 repeatedly down my paper. I probably didn't, do my thing right for this. But 14 plus 14 would give me 28. So my multiples would be 14, 28. Add another 14, I'd get 42. Add another 14, I'd get 56. I could keep doing that with both 14 and 18. Oh my, see, I don't even know this one. 36 plus 18. What's that? 54. 72. Okay, so I went right past that. 90. Not close. Let me come back to my 14s. I'm trying to look for a number they have in common. Do you sense the futility of what I'm doing? It is going to take me a very long time here to get to this answer. In fact, I might be working all day and I might make one simple mistake in my addition and miss where they run into each other. And so even though finding the least common multiple by just listing out multiples is the easiest way to think about this problem, it's not always the easiest way to do this problem. If they run into each other really quickly on their times tables, well, hey, easy. Life is easy. Or if you know those times tables, again, life is easy. If it's a really easy number to count by, like 10, life is easy. But when it's like this, it's more challenging numbers. We don't know their times tables. Man, we need a better way. And that is when teachers will often use another method known as the prime factorization method. Now, for those of you who've never done prime factorization before, I have a full hour-long, or maybe not hour-long, but at least 20-minute video on it. I would pause this right now, go check out the prime factorization video, or you'll be a little mad at me, because I'm going to assume you know prime factorization. Okay, here's how the prime factorization method works. What you do is you build a multiple out of prime factors. But first, it's important to break the two numbers that you have, I have 14 and 18, down to their prime factors. We want to see what they're made of. In order to do that, I'm going to use a factor tree, just like I always do for prime factorization. Well, I know 14 is the same as 2 times 7. As far as 18 is concerned, I know it's the same as 2 times 9. Now, 2 is a prime number, so I'll stop. 7's a prime number, so I'll stop. That's why I just stopped with 14. But when you think about 18, it is made of 2, which is a prime number, but it's also made of 9. 9 is composite. I'm going to keep going. 9 is the same as 3 times 3. 9 is composed of 3's. Okay, so what did I just learn here? I just learned that 14 and 18 share a common number of 2, but the other things they do not have in common. If I want to build the least common multiple the first time that these numbers run into each other, what I'm going to have to do is I'm going to have to include every factor that I see. But the interesting thing is that I don't need to repeat. So if a factor is shared, for example, the number 2 is shared here, I only need 1 2. They both share a 2. I don't need to have 2 2's inside of my least common multiple. They each have a 2. The 2 is accounted for. So I will definitely have a 2 in my least common multiple. Now notice I'm going to multiply factors together to build this common multiple. I put a little 2 sign after my, or a little times sign after my 2. Okay, so 2 times. Now, there is a 7 in 14, so I am going to have a 7 to build this least common multiple. And there are also a couple of 3's in 18. I am going to have those 3's in order to build my multiple. I'll take every factor that I have, not repeating the shared ones, and I will multiply those two together to find the least common multiple. So 2 times 7 is 14, and 3 times 3 is 9, and I'm going to have to, do some side work because I ran out of cool. 14 times 9, let's see, that's 36. 10, 11, 12, 126. Turns out if I'd have persisted a little longer, I probably would have found that. But this was an easier way to do it, okay? It's building a least common multiple out of all the factors you find inside the numbers. Again, if a factor is shared between both of the numbers, you do not need it twice. And so 126 here is the least common multiple. And indeed, if I would have kept going, you would have seen that. The next one would have been 112 up on here on the 14. Next one would have been 126. And then here, if I added an 18 to 108, I would have gotten 126. Okay, so prime factorization can be built, and that is more of a high school skill. And it's tricky, so let's try one more to make sure we understand. Let's think about 24. Now, 24, you can use any multiplication factor you know about 24, just like always with prime factorization. Prime factorization is unique, so it doesn't matter. Which way you go, we'll always get to the same answer. So let's see, I know that 24 is the same as 6 times 4, but 6 is 2 times 3, and 4 is 2 times 2. And now these are all prime factors, and so I've reached the end of my branches and I'm done doing the factor tree on 24. Now let's try factor tree on 32. Let's see, what do I know? I know 32 is the same as 4 times 8. Now a 4 is a 2 times 2. 8 is the same as 2 times 4. I'll stop with my 2. I'll keep factoring my 4. 2 times 2. Now, I see some things they share. These two numbers share a 2. So again, I don't have to double it up if they share a 2. But careful, they don't just share 1, 2, they share some more. So they share another 2. So I'm going to cross 1 off of each of them and give myself another 2. And can you have repeated numbers? Yes, if they both have repeats of the same number, you're going to have it. So let's see again. I see another 2 that they have in common. Now, there are some numbers they don't have in common. 24 has a 3. I have to include every factor I see. So it's going to get my 3. And then 32 has a couple more 2's. I need them both in there. Okay, why do I need to do that? Because I need every factor that's here. So they each had 3 2's. 1, 2, 3 2's. And then plus I have all the extra factors. Extra factor, extra factor, extra factor. And that way I can build. The first time they're going to run into each other is when I have all their factors considered. So 2 times 2 times 2 is 8. And 3 times 2 is 6 times 2 is 12. And 8 times 12 is 96. And maybe you're impressed by my multiplying ability and you would need to do a little more side work. And that's fine. But if you had this problem on the GED, least common multiples, they do come up on the GED. It would be on the non-calculator section. So it's important that you can do these computations by hand. Wonderful. So the first time 24 and 32 run into each other is at 96. So least common multiples can be stumbled upon by listing out multiples. They can be built out of factors. Whichever way you do it doesn't matter. Like, you know, use whichever tool is easier for you. However, it's important that you know both, because sometimes one way is the best way and sometimes another way is the best way. And students who are like, I only want to learn one method, make me laugh all the time, because I'm like, I just imagine if you were a carpenter who said, I only use hammers. And I would be like, you know, hammers are useful when we're doing certain things, but they're not that useful other times. It's nice to have other tools in your toolbox beside a hammer. So anyway, it's really nice to know both ways to find an LCM. Okay, so if you have any questions about this or any other math concept, feel free to drop them in the comments. And as long as you're not out of my pay grade, I'll do my best to answer them.